In this video, we are going to solve exercise 18.15, and this pertains to finding the turning points and their nature. That is question number 1. Find the turning point or points on the following curves and explain whether each point is a maximum or a minimum. Part A. Y equals to x squared minus 4x plus 1. I'm going to solve it using method 1 by finding the derivatives. So dy by dx, that will be equal to 2x minus 4. And as you know that the derivative of 1 is 0. So this is it, 2x minus 4. That is the derivative. Now we put this derivative equals to 0. Setting dy by dx is equal to 0, because that will give us the stationary point, and that is also the turning point. 2x minus 4 equals to 0. So 2x is equal to 4, and the value of x is 2. Once we have got this value of x, now we are going to replace this value into the given equation, this one. So y will be equal to 2 squared minus 4 times 2 plus 1. That is 4 minus 8 plus 1. That is negative 3. So this is the minimum. This is the turning point. The turning point is x comma y, that is 2, negative 3. There is another method to find this turning point. That is, and this method is for quadratic equations. If you compare y equals to x squared minus 4x plus 1 with ax squared plus bx plus c, we will come to know that the value of a is 1, b is negative 4, and c is 1. So x of the turning point or the minimum or the maximum point is given by the formula negative b divided by 2a. That is negative times negative 4 divided by 2 times 1, which is 4 by 2, that is 2, as before. Once we have got the value of x, we are again going to use this value of x to replace it in the given equation. So the value of y would be negative 3, and the point is 2, negative 3. Yet there is another method to find the turning point that might give you the nature of this turning point. So let me write down this nature of the turning point. That is, for the nature, we see that the graph is having equation where the coefficient of x square is positive 1. So it would be a U-shaped curve like this. This special shape is known as a parabola, but this is going to be a U-shaped curve. So obviously, this is going to give us the minimum point. So we say that 2, negative 3 is a minimum point. There is yet another method to find this nature of the turning point, and that is to find the second derivative. Once we had dy by dx is equal to 2x minus 4, now we need to differentiate it once again. We need to calculate its second derivative, that is d2y divided by dx squared, that is going to be positive 2. Now we need to replace this value of x that we got by substituting dy by dx is equal to 0, and that value of x is going to be replaced here. Since this second derivative expression is void of x, so we cannot replace this x equals to 2 here. So that means this second derivative value is positive in all the cases and all the values of x. So when the second derivative of a given function at this stationary point, having the substituting this x value into the second derivative, if that generates a positive value of the second derivative, as is the case like this, so that is a symbol, that is an indication that that is a minimum point of the curve. And obviously, as I have already told, that the methods to find the minimum point are either this one or this one, and the nature is the minimum point, whether you do it with the second derivative method or you do it according to the coefficient of x square, as I've explained it. So these are the two methods to calculate the turning points and their nature. Okay, now we do it. The second part, the part B, x squared plus 6x minus 4. So the turning point can be calculated as we did previously by taking the derivative, the power or the exponent of x that came in the beginning of the variable, and then x raised to the power 2 minus 1, then 6 times the derivative of x is 1, and then derivative of 4 is 0. So 2x plus 6, that is this first derivative. So now we set dy by dx is equal to 0. 2x plus 6 is equal to 0. That generates negative 6 by 2, that is negative 3. Once we have got this value of x, now we are going to replace this value into the given equation, this one. So y is equal to negative 3 squared plus 6 times negative 2 minus 4. This is 9 minus 12 minus 4, which will give me 9 minus 16 and sorry, there is a mistake. I need to see. There was negative 3 that I had to replace here. So 9 minus 18 minus 4. This is minus 9 minus 4. That is negative 13. So the xy point is negative 3 and negative 13. That was one of the methods that we did. Now I can do the second method as well. Comparing this with ax squared plus bx plus c. we see that the value of A is 1, like this, the coefficient of x square. B is 6, this one, and C is -4. So now I replace these values into this formula, -2 b divided by 2a. That is negative times 6 divided by 2 times 1. That is -6 by 2, -3. You see the same value of x as before. So now replacing this value of x into the given equation, that will give us the value of y to be -13, and the point is going to be again -3 and -13. Okay, then the nature. Again, method 1 would be the shape of the curve that is determined by the coefficient of x squared. This is +1 x squared. So the shape would be like this. So that generates a minimum point. So this is how you can do it. And for method 2, we had the first derivative to be 2x plus 6. Now we take its second derivative, d2y divided by dx squared, that is 2 times 1 plus 0, that is 2. So as was the case in part A, this second derivative is all the times is greater than 0. So that means that is an indication that it would generate a minimum point. So this is the turning point, which is actually a minimum point of the curve. So this is how we do these parts, part A and B. Now I do part C.